Welcome back to Pre-Algebra with Miss Betsy. I'm glad that you've joined me on our discussion of solving equations that include fractions in them. For my text, I'm using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition, and I am in section 6.8 on page 203, and it's called Problem Solving, Writing an Equation. Before we get started, my lame joke for the day. I know some of you just live for this. Most of you would prefer to throw things at me, but that's the advantage of using a video camera and me being on this side of the screen and you being on the other side. Got a question for you. What do you get when a dinosaur skydives? You get a very large hole. So let's go ahead and talk about some strategies real briefly of what you would do if you were going to solve a word problem. And a lot of people have always just been really afraid of word problems. They think there's all of this information there and there's really no way that how am I supposed to be able to figure out what it is that they're talking about? They have what they call a 4-point checklist, and it's actually a little bit almost hard for me to write this down, because it's pretty obvious what you need to do. But sometimes it just helps us a whole lot to have something written off that we can look at. Step 1, Step 2, Step 3, and Step 4. This is what you need to do when you want to solve a word problem in math, or when you want to solve an everyday life problem, particularly if it's written down for you. What's the very first thing that you should do? Believe it or not, this is what a lot of people don't do. You need to read the problem. You need to read the whole way to the problem. You need to read not to the part of the way through the first sentence, not to the period at the end of the first sentence, but to the very entire end of all of the descriptions that they give you. You have to read every piece of information. You have to make sure that you can go back and say, okay, they've given me this information. What exactly is it that they're asking me for? And are they asking me for more than one piece of information? So your most important thing to do, the biggest piece of advice that I can give you, suggestion to help you with word problems, is say, take your time and read your question. Make sure that you understand what is being asked. Make sure that you've read the entire question. Second, what do? You read this and you say, oh, okay, well the answer is 25. No, you have to come up with a plan of attack. Now, what am I going to do to arrive at this solution? So take a little bit of time, sit and write a plan. I didn't make the effort, which I could have, I'm sorry, I didn't make the effort to find the person who originated this quote, but it's very good. If you fail to plan, then you plan to fail. And you could talk about this in all sorts of different aspects of our lives, all different ages. If we don't take the time to sit down and plan what we're going to do, then you've almost, in a lot of cases, almost guaranteed that you're not going to be able to come up with the result that you were looking for, or you're going to be so stressed by the time you come up with a solution because you haven't taken the time necessary to sit and come up with a plan of attack. Okay? Finally, next, once you have planned what you're going to do, you've read it, you know exactly what it is that you're being asked to find, you've come up with a plan of attack, go through and carry out that plan and come up with a solution. And this right here is where bunches and bunches and bunches of people stop. Maybe they'll read part of it, they'll make a guess as to what to do, and they'll come up with an answer, and that's all they do. They don't take the time to do the final solution, which right here I messed all up with my book, but it's check. It's take the time to go back and say, okay, if this is what I started with, does this answer that I came up with make sense? If it's asking how fast I am running in a 25-mile foot race, which I would just sort of pass out, after the first half a mile. But what's the speed that I'm traveling, and how long did it take me to go? Well, okay, I'm running 3 miles an hour. That's very slow, but it's a slow, steady race. So if I'm going 3 miles an hour, that could be reasonable. How long did it take me to run the race? 35 hours. 35 hours, really? It's only a 25-mile race. How could it take you 35 hours to do that? See, there's a disconnect. The pieces of information aren't right. So take the time to go back and check. So you've read your problem, you've come up with a plan, you've solved your problem, and then you take the time to go back and look at your solution and check it. Does it make sense? So that would be the basic way to handle a problem that's been given to you. Now, some of the problems that you're given, particularly in math, you solve them by coming up with an equation, writing an equation, and then solving it. And how are you going to do that? Well, a little bit more specific information here. First, you're going to represent the unknown with a variable. Represent with a variable. If they're asking you for the speed of the car, you might say, let x equal the speed of the car. And then they might give you other conditions, other situations, and I'm going to copy this exactly. Represent other conditions in terms of that same variable. That same variable. For example, let's say you have 2 cars, and it says one car is traveling 20 miles an hour faster than the other car. What's the speed of their cars? Okay? We would have to have more information to be able to come up with an equation, but let's just say let x equal the speed of the first car. So back to my off the top of my head illustration, the second car is traveling 20 miles an hour faster than the first car. So what would 20 miles an hour faster than the first car be? Well, it would be the speed of the first car plus 20 would be the speed of the second car. And this is what they're talking about in step number 2, the speed of the second car. They're telling you to represent other conditions in terms of the same variable. Figure out what x is, or m, or p, or s, or whatever relevant variable you decide to select. A lot of people just use x for everything. Your other things that you're trying to find are going to be written where you've included that first variable. There's a relationship between it. We don't know what the speed is of the first car at all, do we? No. But we do know that the speed of the second car is 20 miles an hour faster than the speed of the first car. So here's the speed of the first car, x, plus 20 gives us the speed of the second car. And then you continue looking at your equation, you figure out what's equal, and you write and you solve an equation for, if we had said, the speed of the first, there are 2 cars that are traveling. The speed of the second car is the speed of the second car is 20 miles an hour faster than the speed of the first car. The speed of those cars combined, as I'm creating this in my head right now, is 70 miles an hour. Okay? The speed of the first car, so we're going to say let x equal first car's speed. X plus 20 is the second car's speed. Car's speed. Figure out what's equal to what. Come up with a relationship. Well, the speed of the first car plus the speed of the second car, what did I say, was equal to 70? We'll say it's equal to 70. 50 plus 20, 40, 20. Let's say the speed of the cars combined is 60 miles an hour. So we have the first car plus the second car, their speeds, what does it equal? 60 miles an hour. What is going to be the speed of the first car? X. Plus the speed of the second car, x plus 20, is equal to 60. Combine like terms, 2x plus 20 is equal to 60. Now we have an equation that we can completely solve. We're going to subtract 20 from both sides of the equation to get 2x is equal to 40. Now we can divide both sides of the equation by 2, and we figure out what? X is 20. What is that? That's the speed of the first car. X plus 20 is 40, which is the speed of the second car. And their speeds combined equals 60 miles an hour. So this is an example of what they want you to do. They want you to pick a variable to represent what you're looking for in your problem. If you have other pieces of information, come up with an expression where you use that same variable. Create a relationship between the two of them where this is equal to that. Solve your equation, check your solution. And it looks maybe not quite so easy when they're just talking theoretically or just giving you a bunch of sentences and some English verbiage as to what you do when you're solving an equation. But let's go ahead and do an example for you. So we have 4 steps that we're going to follow. First we're going to read, then we're going to plan, then we're going to solve, and then we're going to check. Here we have example 1, or example. A carpenter is nailing baseboard molding along a wall that is 88 inches long. He has nailed in place a piece of molding that is 32 5/8 inches long. What length of molding does he need to finish the job? So what are we supposed to do? Well, we have to read it. Obviously, I just read that out loud to you, but what is it actually telling us? It says, okay, he's got this piece of board, or this wall right here that he's putting molding on. And he's already put a piece of molding down there that is 32 5/8 inches long. They want to know how long does this second piece of molding here need to be so that he has the entire molding along the entire length of this wall. And our piece of information, our problem tells us that the entire wall has a length of 88 inches. So what can we do? We have to figure out what this is. So first, we have to say, let's just let our variable be called x. And that's where we want to figure out how long this board has to be. Looking at this information, what relationship can we say? Well, both of these 2 little sketches that I have here are the same distance, aren't they? Same length, 88 inches. So if we were to write an equation, what could we write? Well, we want to have our variable let's go ahead and write that on the left-hand side of the equation. So we can say that x plus 32 5/8 is equal to 88. The lengths are the same. Our bottom sketch here is just 88 inches. Our second sketch is going to be 32 5/8 plus whatever we're missing to add onto the short piece of molding that we already have, so that we have a total length of 88 inches. So now we've got our plan, we've written our equation, we just need to solve it. How are we going to solve it? You're going to subtract 32 5/8 of an inch from both sides of this equation. X plus 32 5/8 minus 32 5/8 is equal to 88 minus 32 5/8. So x is going to be equal to 88 minus 32 5/8. Now all you do is do your subtraction of the fractions. You'll remember that if you wanted to subtract this vertically, 88 minus 32 5/8, you can't subtract 5/8 from 0, can you? So what would you want to do? That's right. You would want to rename 88 as 87 8/8 minus 32 5/8. Do your subtraction, and you would determine that the length of your piece of molding that the carpenter has to cut is 55 3/8 inches would be the length of the piece of molding that our carpenter needs to cut. Now I said that the final most important, in some ways, most important step to solving a problem is to actually check it. What did we say x was equal to? 55 3/8. So we'll substitute this value into our original equation, and we'll say 55 3/8 plus 32 5/8. Is that equal to 88? 3/8 and 5/8 is 1. 52 and 32 is 87 plus the 1 is 88. So we see that our solution is correct. So the problems that you're beginning to do, they're challenging to you because they're new to you, but they're not huge, hard, difficult things. It just is teaching you to be methodical about the approach that you use and taking the time to check your answer. That's the end of Chapter 6, and I'll see you when we begin Chapter 7. Enjoy your problems.